Okay, so we have one last thing to talk about, and that is how to find the mean and standard deviation of a binomial distribution. So mean and standard deviation of the binomial. And as it turns out, there's some formulas that make this very, very easy to do. Okay, so if you recall, the way we found the mean and standard deviation of a random variable, so let me just bring this one into play, or just as an example. So the regular formulas for any probability distribution, to find the mean, for example, you take 0 times this probability, 1 times this probability, 2 times this probability, and you do it for all the values, right? And then you add those together, and that's the mean. And then you had the formula to find the standard deviation. Okay, so you can think of that as kind of the method that'll work for any probability distribution, even if it's not binomial. Okay, but if you know that your distribution is binomial and you know n, p, and q, then you have really nice shortcut formulas that make this very easy. And in fact, the mean is just n times p. Just n times p. That's all you have to do. Makes it very, very easy. And here's the amazing thing, and that is that the standard deviation is basically just n times p times q. Believe it or not, it's just amazing. But that actually gives you the standard deviation. I'm sorry, that'll give you the variance, and then when you take the square root, that gives you the standard deviation. So n times p times q, believe it or not, is the standard deviation for a binomial. So let me just give you an example here. Let's do the original one where we said we had a sample of 50 people that were exposed to the disease. The probability of catching the disease was 0.03. So the probability of not catching it was 0.97. And so what I was going to say here is that the mean, then, all I have to do is take 50 times 0.03. So 50 n times p. And so we get 50 times 0.03. And I get 1.5. So what is the expected number of people that'll catch the disease? It's 1.5. So on average, you'd expect, if there's only a 3% chance of catching it and 50 people are exposed, on average, you'd expect 1.5 people to catch the disease. Okay? And then the standard deviation is just 50 times 0.03 times 0.97, and then you take the square root of that. It's that easy, believe it or not. So 50 times 0.03 times 0.97. So hit equals, and that is the variance, 1.455. And then if I take the square root of the answer, I get the standard deviation, which is approximately 1.2. So on average, you'd expect 1.5 people to catch the disease with a standard deviation of 1.2. And yes, it's that easy. It's pretty amazing. So let me give you a chance to give this a try with a few problems here. So these are actually the ones that we did when we practiced the binomial probability formula. And so what I want you to do in this case is calculate the mean and standard deviation in each example. So I'll give you a moment. You can press pause. I'll give you a moment to do that. And then when you're done, go ahead and play the video again and see how you did. Okay, so let's see how you did here. So this first one, we got to find N, P, and Q. So 45% of the people favor the tax law. 25 people are selected at random. And you want to find the mean and standard deviation of the number of people who favor the law. So the success is they favor the law. There's 25 trials, 0.45 is the probability of a success. So the probability of a failure is 1 minus that, 0.55. So the mean is just 25 times 0.45. So 25 times 0.45. And you get 11.25. And this actually makes sense, because if you have 25 trials and 45% of the people in the population have or favor the law, then you would expect it to be 45% of the number of trials, right? 11, which is 11.25. So that actually makes sense here. But then it's amazing, the standard deviation will just be 25 times 0.45 times 0.55. That's all you got to do is multiply the three numbers together, take the square root. It's beautiful. Okay, so I take 0.25 times 0.45 times 0.55, and that actually gives me the variance. So I think on the homework, it'll probably ask for the mean, the variance, the standard deviation. So there's the mean, this is the variance, and then I take the square root of the answer. That gives me the standard deviation. So that's approximately 2.5. So I'm going to round it to the tenths place. And I suppose I could have rounded that to the tenths place. I would round it to however many decimal places they tell you to round it to on Connect Math, on the homework. So, okay, here it says at a particular store, 15% of the shipments arrive later than scheduled. If 35 shipments are expected, then what is the mean and standard deviation of the shipments which arrive on schedule? So in this case, n is equal to 35. There's 35 trials. Now the success, though, isn't the 0.15. That's actually the failure, because the success here is that they arrive on schedule, so I want to take 1 minus that, and I get 0.85 for P. So then the mean is just 35 times 0.85. So 35 times 0.85. That gives me 29.75. So that's what you would expect. That's the expected number that are going to arrive on schedule. And then the standard deviation is just 35 times 0.85 times 0.15. Take the square root of that. So here, notice I already got 35 times 0.85, so now I can just take the answer times 0.15, simplify it a little bit. That's my variance. Take the square root of the answer. That's my standard deviation, 2.1. Okay, so that's the mean and standard deviation. And now the last one here. So out of every 50 compact discs that are produced, 1 out of every 50 is defective. And what is the mean and standard deviation of the number of defective discs for a pack of 50? So the number of trials is 50. Each CD in the pack is a trial. The probability of it being defective, which in this case is the success, is 1 out of 50, which is 0.02. So the probability of it not being defective, the failure, would be 0.98. And so the mean is just 50 times 0.02, which I think is going to be 1, right? 50 times 0.02 is 1. You'd expect 1 to be defective, and which makes sense because 1 out of every 50 is defective. And then the standard deviation is 50 times 0.02 times 0.98. And then you take the square root of that. So 50 times 0.02 times 0.98. That would be my variance. Take the square root. That's my standard deviation. And that would act, if I rounded to the tenths place, that would be 1.0. So in either case here, It's a mean of 1 with a standard deviation of 1. Okay? So that's the idea. The mean and standard deviation of a binomial has a really nice, easy shortcut formula that you can use, and then you can find the mean and standard deviation.